Good evening, everyone. Good morning if you're in the US. Today we are welcoming the Salad team, Shawn and Shawn. Hopefully, I'm pronouncing it correctly. And Gabrielle as well from Pruna. They are going to share how you can use Salad and Pruna to really optimize your inference endpoints and go faster, smaller, and cheaper. Um, Gabrielle has built an amazing tool to present as well. So there'll be a short demo and be ready because you will receive a link to test it as well. So you can have some fun during the event. So I'll give the stage to Gabrielle.
Yeah, thank you, Nanny. And hi, everyone. Thank you for attending. So I'll start by showing a little bit of introduction of what Pruna is, and you understand how powerful it is combined with Salad. So and by the way, I'm software lead here at Pruna. So what I'll show you is some code that we developed together. So yeah, just a bit of context. Generative AI is everywhere now. Everyone's using it, whether that's professionally or in a personal life. It's becoming so heavily used that companies are using it increasingly, and there are many open source models that anyone can use, and any company can build a solution from. Now, there are many scenarios in which you want to deploy your own model on your infrastructure, whether that's for privacy or because you're deploying something that does not exist in an API endpoint. Many reasons may exist. One thing that you'll realize is that it can cost you a little bit. If you take Amazon, for example, with the H100 machines, so there's one that has 8 machines. This is slightly old because now I think they have the single H100. This is a bit cheaper, but divide by 8 and we can kind of see that it's still going to cost you an arm and a leg. And if you factor in scaling, then you will end up paying quite a bit. So what can we do against this? Well, one way is optimizing the algorithm itself. There are many techniques that you can use to make a model faster and smaller. Sometimes smaller equals faster, and I will not get into all of these techniques, but what I can say is all of these techniques individually have good impact, and they can be combined. And a good example of this is this. So this is for a Fox Hubble when you're on a GPU L40, and you can see that the base model by itself is running in about 15 seconds to double that. If you just apply one of our techniques, you can get that to already 5 seconds, 3 times as fast, which is already amazing. And if you combine everything, a lot of techniques like with compilation, quantization, for example, which is what we've done for this demo, then you get to about 3 seconds. Now, this will change depending on the hardware that you have. What we'll show you today is about 4 seconds per inference, but Salad is a unique cloud provider where you can use consumer GPUs and let you present. So we'll get similar results than L40, which is awesome. And yeah, that means that Pruna with Salad is a very powerful solution to have something deployed that's quite cheap and very scalable. And so over to you, Shawn.
Phenomenal. Thank you for that intro, Gabriel. Well, excited to continue sharing a little bit about Salad Container Engine. I think the reason why we're so excited for this partnership with Pruna is because while Pruna is bringing the speed to AI models, Salad is bringing low cost and massive scale of GPU resources to the market. So with the combination of all three of these different value propositions, it almost makes it a no-brainer to use Pruna optimized models on Salad Cloud. So rewinding about 7 years when Salad was first founded, we set out on a mission to be the world's largest distributed, decentralized global GPU cloud. We started in the crypto space, first and foremost, building up our supply side of the network. Over 7 years, we've aggregated over 2 million compute suppliers, mostly residential machines, often gaming PCs in individual homes of folks that are wanting to take their gaming PCs, which are often offline for 20 to 22 hours of the day and leverage the network of Salad and our demand to run a wide variety of applications. And as I mentioned, that started in the crypto space. And then about 3 years ago, we started on this journey for AI and cloud compute, serving our customers from a demand-centered focus. Today, that's launched through our first product, Salad Container Engine, which allows customers to deploy containerized workloads on our network across a wide range of hardware, all the way up to RTX 5090s and down to the GTX series of the 1000 series cards. We've also recently added in some partnerships with data centers, so we're also the cheapest cost H100s, A100s, and L40Ss. Because of the nature of our business, it's a two-sided marketplace. We have individuals that are renting machines to the Salad network, and we have customers that are renting those machines. The metaphor we like to use for some of our customers is it's kind of like the Uber model, but instead of renting rides and drivers, we're renting gaming PCs to AI companies and research companies that need a massive amount of compute at the lowest cost in the market in order to be effective. Now, that's all great, very theoretical. I want to pass it over to Shawn to talk a little bit more about how this works at scale. So, Shawn, go ahead.
Hey everybody, I'm the other Shawn. I'm our lead solutions engineer over at Salad. So yeah, we're a two-sided compute marketplace, and what that sort of looks like is on one side you have developers specifying the hardware that their workload requires, CPUs, RAM, whatever GPUs you want to run it on. On the other side, we have our compute hosts, which we call chefs, and they kind of set some parameters on how we're allowed to use their PC, and it just gets matched up on the back end. Go ahead and give me the next slide. So our chefs are really all over the world. We're in more than 150 countries and more than 1,300 states and provinces within those countries. You can see it's not evenly distributed though, right? Like it's going to be pretty much along the lines of where there are people with GPUs and the internet. So it's pretty concentrated along with population density. And you're going to have other things that are pretty predictable when you think about them, like the 5090s and 4090s are going to be mostly in Western Europe and the US. There's a lot of RTX 30 series GPUs in India. And you're going to see other patterns like that where it's mostly pretty predictable, like how the distribution's actually going to be, but it's pretty big scale. Yeah, so that's where we are. And how it actually works under the hood. So our chefs install a Windows desktop app and set their preferences. What that does under the hood is we install our own security-focused lockdown Linux distribution called Salad Enterprise Linux in WSL2. And then we're able to use WSL2's kind of built-in virtualization hypervisor features to run containers in a sufficiently isolated environment. And yeah, whenever their machine is idle, like our app has a little detection thing that just tells when they're not using it anymore. Then it'll reach out to Salad and be like, hey, I am an RTX 5090 with 32 CPUs and 60 gigs of RAM. Please give me a workload. And then we're going to give them the highest paying workload that's compatible with their hardware, and that's available. And that's kind of it. It's not super complicated, honestly. I mean, like under the implementation details get a little bit complicated, but yeah, it's really just we run Docker containers on idle gaming PCs, and that turns out to be great for a wide variety of applications. In particular, if your application fits in the VRAM of a gaming PC, which is where partners like Pruna are great because they're able to like shrink models so that you have a model that maybe previously you needed an A100 or an H100 or something for, but now it fits in a 4090. And, so instead of paying multiple dollars an hour to AWS, you can pay us like 20 cents an hour and just run it on an idle 4090. So yeah, that's how Salad works.
Well said, Shawn. Well, I wish our customers always responded with that same philosophy of, oh, it's not that complicated under the hood. It's just as easy as running AI applications in 180 countries around the world and all the complexities that comes with that. But the go-to-market here has been really interesting. And I think it fits an overall global narrative, right? We see the top foundational model companies at OpenAI and Anthropic making data center partnerships every day of the week. It fills up my newsfeed. I'm sure it fills up all of you all's being in the space. Every single day of the week, we're seeing new data center announcements and new data center builds coming out across the US and countries around the globe. What we are doing here and what we see is, of course, we believe there's going to be a need for more inference, a need for more data centers. We're going to need more compute, but we also see a massive market of 400 million idle gaming PCs that are out there in the network that we can operationalize for 20 to 22 hours a day when those resources are sitting idle. But this go-to-market problem has been a really kind of two-pronged way of us solving. And so I wanted to share about how we've done this before Pruna and then what Pruna adds in additional before we get into the demo specifically here. So when we launched this product a little over 2 years ago, part of what we needed to do was prove that, hey, this distributed model actually does work, right? It actually isn't that complicated under the hood, and we can push this out to customers across a wide variety of use cases. So Shawn leads our solutions engineering team here at Salad, and what the solutions engineering team does in particular is go and benchmark models. Of course, customer support, all the fun stuff under the hood, but specifically, we are benchmarking all the best-in-class models and understanding how they work, not only from a cost-effective position on Salad, but also inference times, all the things that you as a developer would be thinking about, and whether or not you needed to use a data center for this compute, or whether you needed to use, or you could use a distributed GPU and save the cost of running in a data center. And so as you can see on here, these are screenshots from many different benchmarks that we've run internally, everything from Flux One Dev, which I'm excited to share even some of the new advantages that we have on this side, because Pruna outpaces this benchmark that we did, over to video generation, LLMs, dirt cheap image captioning, as you see there, Blender, a bunch of GPU intensive resources. Our solutions engineering team has dove into that. But it's not just benchmarks where we found success. If you go forward to the next slide, we've also launched a series of case studies with customers in a wide variety of fields showing how our GPU compute can be operationalized to serve customer workflows. One of our foundational customers and early adopters of Salad, Civitai, powered 10 million images a day at peak on Salad's distributed cloud. Undetectable AI was running large language models, and at their peak, they reported over $1 million of savings, even more than what was at the case study when we published it. Sogny leveraged the Salad's distributed GPU cloud to scale massively in their user count nearly overnight, and they needed ways to get GPU resources cost effectively. And then one of the new exciting use cases that we're seeing emerge on Salad is AI drug discovery workloads. So molecular simulations, drug discovery, and biotech research is another exciting use case on Salad that takes a bunch of GPU power, and all of our customers would prefer to do that at a cost-effective rate. But it's not just these two things that we've been able to prove. With the partnership with Pruna on the next slide, we've been able to make this even better and even more cost efficient. So I'll pass it over to Gabrielle to continue the conversation and share how this is planning out.
Yeah, thank you. So is demo time. Yeah, we're back to the previous slide afterwards in the end, I think. So let me show you. So I've got this little Gradio app. If you don't know Gradio, it's a Python library that you can get that's developed by Hugging Face, and it enables me to actually, me who's not really a front-end developer, to give you an interface, and I've got a link that is managed by Hiding Face with their servers in the US, so that I can share with you this app. So you will receive in the chat a link that you will be able to use, that you can test it yourself. And basically, on this interface, you'll be just able to generate as many cat images as you'd like. It takes about, on this app, about 5 seconds to generate something. So we get about 1 second of latency because all the traffic probably that is going on and the slowness of radio. Let me show you what it looks like when you run Salad. So this is my application that's deployed on Salad. I've got 3 machines that are running, one that is actually turning on. So it's getting to 4 currently. And to give you an idea of the price, it's about $2.2 an hour. So that's pretty cheap for serving a Fox model. And I can access here the terminal for one machine, and I'll just show you how fast it is on the machine so that you get the true number for speed, which should be about 4 seconds. So 4.4 centimeter times. Sometimes you get 3.7, sometimes you get 4. There's a little bit of variability depending on the machine, because it is a consumer machine. It's about 4 seconds. And so demo time and question time, let me share with you this lake so you can have fun generating some images, try it out for yourself. And thank you for your attention. I'll just go to this slide and let me know if you have any questions.
And as those questions are waiting to be rolled into the chat, as we did on that last screen, Salad, in partnership with Pruna, is able to offer some fun incentives for folks to go on the network and test using Salad Cloud. So for all attendees, we're offering $50 of credits, good for a few months for you to get in, test out Salad. We have plenty of recipes, which are our quick deployment solutions, to where you can go in and deploy either one of Pruna's models yourself and test out, or a wide range of additional models that we have on the network. And if you happen to be here representing a company that runs a large amount of compute, you are, of course, our friends. We want you to run on Salad to save those costs and to increase your scale. We can offer up to $10,000 of credits for companies running inference at scale. And typically we define that as companies running over $50,000 a year in compute. And so if you're in either of those categories, one, wanting to test on Salad, or two, wanting to run your company's inference on Salad, please reach out to cloud@salad.com, throw Pruna plus Salad in the subject line, and we'll either add those credits to your account for testing, or we'll talk to you more about what the steps look like to qualify for those credits as a company. But do we have any questions in the chat, Gabriel?
I think we had one. Does Salad AI use Salad compute? I'm guessing you said so already, so the answer is yes.
Yes, they do. We actually have a really fun benchmark that I can pull up while we're chatting a little bit more. But yeah, they were one of our early foundational customers that joined on to Salad when they were scaling up their product themselves in the early days of the adoption of generative AI, especially image generation. And so we're able to not only learn a bunch about our product as they continue to gain demand and work on Salad, but also figure out the best ways to help customers at that scale of resource. You know, those top 50 A16Z company list type of customers run on Salad Cloud Compute. So Shawn actually worked with their account a decent amount on that side. Shawn, I don't know if you have any additional comments on the Civet workload while other folks are continuing to ask questions.
I mean, they have a pretty clever orchestration layer that, because anybody that's used Civetai, you know, they have a huge number of models that they support. So there's some clever orchestration into getting requests to machines where the model's like already downloaded and loaded and stuff like that. So that was like a cool scheduling problem to work on. I also see a question I can take about the expected cold start for a 4090 on Salad. It varies with, of course, the size of your Docker image and with the local network conditions of various nodes. So it can be anywhere from like a couple minutes to tens of minutes, really, depending on those factors. What we sort of see is like when you start a container group, like a set of multiple replicas in Salad, there's sort of like a warm up period where all the machines are coming online. And then after that, they're basically all going to be online minus like one or two, like basically like minus a small percentage that are going to be involved in reallocations at any given time. So yeah, anywhere from a couple minutes to tens of minutes, depending on your workload and the node it lands on.
It's actually a really interesting problem that we've tried to solve at scale as well, and introducing some additional features onto nodes themselves. One of the things that we've released in a beta form and then we'll launch in full production across all of our customer accounts is image caching, optional image caching for those that want to opt in and get quicker cold start times. So storing layers of different container groups that are the most popular across the network onto the devices located around the world, and then basically using our backend matrix that assigns all the workloads to different nodes and preferring those nodes that already have the most pieces of your container on those devices, speeding up that cold start speed. So I think at peak, we were getting close to 25% better cold start times. And then we'll continue that to scale as we continue to do more caching across the network. But yeah, I'm sure you can only imagine in a distributed compute environment with how global we are, how difficult cold start times can be with the challenges of residential internet connections. So getting that cold start time down, I think I'm as quick as I can. How quick.
I see another question around using Docker directly. Well, it's not really a question, but more of a comment. The issue I'm having is that they can directly use a model doesn't directly use Docker under the hoods, and that can be an issue for a setup. Yep.
Yeah, we're a fan of containers. They're, a great convenient way to package your application in a portable way that you can sort of expect to run in a lot of places. So yeah, we support Docker and OCI images, and I think everybody should containerize.
Yeah, maybe I can show. Oh, so you already showed it during the presentation, but this is the pricing that you had. So, Jeremy, if you want to use a 4090, you can use Pruna to just optimize the model so it fits on the 24 gigabytes, and then you get 30 cents an hour for this GPU. And then just scale up to a few machines so that when the gamer wants to game, then your service doesn't go down. And but you should do this anyway for any kind of production level application, so that you can just have one machine running in the road. So that does not really change. And yeah, this one is so this is running on the RTX 5090 for a monthly cost of 1,600 compared to the 56,000 from Amazon. It's a bit of a difference.
That's amazing. And thank you for bringing up the pricing there, Gabrielle, because we actually just dropped prices again on Monday. So we're very excited to continue as we're both optimizing and growing the network to reduce the prices of our network to continue to be the most competitive in the marketplace as well. Our value prop is to be the floor of GPU pricing while also being the largest at scale. So it's very exciting to see customers recognizing that in the chat and everywhere that we are the lowest cost GPU provider as well. And so I threw in the note sharing a little bit more about those GPU pricing, how they may be compared to some of the competition in the marketplace. We're very excited again for those price drops.
And bear in mind, this is for 4 replicas. So for developing, just divide this by 4, and then you get the best GPU for consumers available. Focus, 400 a month. So the price bar, what is it in? One of the base instances from Amazon, for example.
Yeah, for sure. You notice on average that are on AWS typically save somewhere between 60 to 80%, or rather any of the hyperscalers, not AWS specifically, but rather Google Cloud and Microsoft Azure as well. And then if you're using another Neo Cloud where the prices are just apparently a little bit cheaper, we see cost savings somewhere in the 40 to 60% range on average, either for distributed clouds like ours, or rather Neo Clouds that are a little bit bigger, but a little bit cheaper as well. So some significant cost savings at scale. While we're waiting to hear back on folks trying the demo, I would also be curious if you wanted to showcase the Pruna recipe in the portal, Gabrielle, while your screen is shared. If you not only wanted to run on this test environment, we've also set up a super easy way for you to run the Pruna deployment at scale. So not only on GitHub, but in the portal directly, there's a button that you go to deploy a container group to where you can easily spin up the image as well. If you wanted to point there, Gabrielle.
Yeah, you're referencing this, right?
Yeah, so if you click on container groups on the left-hand side, and then you click deploy a new container group, and then if you cancel from the thing of this, we let you guys bypass like Google and our customers. I'll do that just to make sure we can make a profit. But if you scroll down a little bit on the left-hand side of your screen under the Ubuntu container there, we actually have a quick deploy. Oh, it's a little bit higher than that. You had it up there just.
Oh yes, here.
We're guiding on the spot here, folks. But yes, for the Flux dev, often to be often tip as simple as clicking get started, and you start your own Pruna image with minimal technical expertise and get your image generated the fastest generation model on Salad. So very exciting.
And one thing I can add is it's open source. So if you want to see it, you can. And it's in these recipes. I don't exactly remember. I think it's in this recipe folder, and you can change the model if you want. So Pruna and Salad, Flux that you just go in there and then got the app code and water file and just change the model name and then it work for another model. If you want Flux, then just click on the button.
Try to make it super easy for optimized models just on very soon from the Pruna ecosystem. So that's very exciting across the board. Melanie, do we have any questions in the chat that we missed?
I don't think so, but if anyone has questions, this is now or never. We can give you a few minutes to ask your last questions. Again, you can get very cool credits from Salad. We're very grateful for them to have set up his credits. You can try Gabrielle's demo. You can try the recipe. So have fun with it. Again, if there's any questions, guys, we will stay a little bit, and then you'll have access to the recording on our YouTube channel. So you can review everything that we showed today. And if you missed it, don't worry, there's the recording. So thank you everyone for attending. Thank you for Shawn and Shawn for their help. Thank you for Gabrielle to set up the demo and the recipes. And again, if you have any questions, either it's now on the chat or you can just contact directly Pruna or Salad anytime you have any question or request.
Phenomenal. I have a question for Gabrielle and Shawn, the other Shawn, while we're waiting for any more questions to pop into the chat. I'm curious from both of your guys' perspective, right? As AI developers who are optimizing these models and who have used clouds, I'd be really interested to hear both of your perspectives on how Salad compares to other clouds in the marketplace. Of course, from the cost, but that's our main value proposition, right? We want to be the lowest in the space. Super curious to hear as you guys have developed on Salad, any other advantages or things you guys have discovered and observations from using Salad for your guys' various tests, both from Pruna models and just models in general.
Yeah, I mean, it's really easy to deploy a Docker image. It's literally copy pasting from your Docker Hub or private Docker in the container group that you're creating for it, and then just deploys it. So if your Docker works, then you've got your model stored. So yeah, very easy, very cheap, and yeah. But it was quite just a stop at the thick experience, I guess.
Yeah, I would echo that. It's easy and cheap to deploy a containerized application. And actually, before I joined Salad, I think I was our first paying customer on the Salad Cloud product. I was at a different startup before that. But yeah, obviously it has way less stuff than like AWS or GCP, right? So that has advantages in that there's really we only have the one thing you can do. So it's very easy to do that one thing, which is deploy containers. And you don't have to get bogged down by I don't know, AWS has got to have 10,000 individual services at this point. It's pretty complicated. I spent a lot of my earlier career was in AWS, and it's been refreshingly simple working on Salad.
you can totally integrate Salad with your existing AWS infrastructure. AWS is still a great offering, and you can pair it up, I guess. So
yeah, absolutely. I mean, like, there's so much we just don't do on Salad, and almost all of our customers are multi-cloud, and they're using us for the GC compute, low cheaper compute, and then they're running like a lot of their more conventional application stack and Lambda or whatever.
Awesome. Very cool to have both your insights. I guess there is no more question from the audience. I think we can leave it here. Everyone can have a good day, good evening, whatever you are. Again, don't forget that very cool email to get credits and also to test the recipes, the demo, and Pruna open source as well. Thank you everyone for attending. Thank you for our guests and hosts, and have a very good day and evening.
Cheers, everyone.
Cheers.
off. Good evening.